We're going to now continue with more review from grade 11. And this is just to remind ourselves of the stuff we learned last year and maybe a little bit in grade 10. These are all the important stuff that's going to be useful for what we're doing here in grade 12. And also we'll be looking at a lot of the same ideas, but instead of degrees, we'll be using it in radians. So we're going to start by reminding ourselves how we label things. So we've got the quadrants. Remember, the first quadrant is up here where x is positive and y is positive. So that's why we decided to call that one the first quadrant. Everything's positive, and it's a good place to start. We rotate counterclockwise, which is good. Just like our rotations, we can rotate counterclockwise to the second quadrant, continue on to the third quadrant, and the fourth quadrant. Notice that we use Roman numerals for those, so we'd like to stick with that. Don't use a 4 here, use quadrant IV or 4, okay? So that's great. And then we have a rule that when we're investigating whether trig ratios are positive or negative, we can use something called the cast rule. And so I know you remember this from last year. And it describes all the spots where sine, cos, and tan are positive, and then you can interpret whether they're going to be negative or not. So remember, the C stands for cos, the A stands for all, the sine stands for, or the S stands for sine, and the T stands for tan. It's too bad that the cast rule starts in the fourth quadrant, and then you go CAST. Because of that, I like to somehow joke and say it's called the ASTC rule. So the ASTC rule, the ASTC rule, but we know it's actually the cosine or the cast rule CAST. Okay. Remember that the cast rule then shows you all the spots where the values of those trig ratios are going to be positive or negative depending on which quadrant. So the cast rule will tell you the ones that are positive. So if it's positive, that means the other two must be negative. So then I can ask a question as you're finishing copying that down. For example, if I said something like, is cosine of 135? Well, 135 is in the second quadrant, which is the S quadrant. I asked for cosine. So sine is positive in the second quadrant. That means cosine must be negative. The good news is it works the same for the reciprocal functions. So if sine is positive, then its reciprocal cosecant is also positive. Because when you take the reciprocal of a number, you don't change the sign, you just change the numerator and denominator. Okay, so that's one important idea to remember. The other one to remember is a related acute angle. And the reason it's so valuable is because the sine, cos, or tan of an angle and its related acute angle are always the same. And so finding related acute angles will make our life a little bit easier than dealing with bigger angles. So first we're going to remind ourselves the related acute angle is the angle between the terminal arm and the nearest x-axis. So two important things. First off, see this the nearest x-axis. We don't refer to the y-axis when we're talking about these angles. Secondly, it's the acute angle. So it has to be something between 0 and 90. So if I look at this example here, you see that I have one going from 0, rotating counterclockwise to 150 degrees to our terminal arm. And I look and I try and find the related acute angle is the angle between the terminal arm right here and the nearest x-axis, which is this guy. So that is my related acute angle. And it obviously comes from 180 minus 150 is 30. So this is the related acute angle. And in this particular example, that's 30 degrees. Looking at the second one, a common mistake I see people do is they tell me that this is the related acute angle 10 degrees. That's not right. It is acute, but that's referring back to the y-axis, and that's not what we want. So that's wrong. The related acute angle is this guy down here, And if we go 100 degrees, we know a full, or all the way over to the other side is 180. So 180 minus 100, and we get that that angle is 80 degrees, and that's related to acute angle for that. We'll look at two more. And if we need to pause the video as you copy down those pictures or catch up, that's fine. So looking at the third example, we have an angle of 220 degrees. So it goes past 180. And this is the related acute angle. So the related acute angle goes back to the nearest one. Since it goes past 180, we're going to actually take 220 and minus 180 and see what we're left with. In this case, we're left with 40 degrees. So the related acute angle is 40 degrees. Again, not going to the x-axis, or not going to the y-axis. Don't go here. This is wrong. We need to go back to the nearest x-axis. Then our final example is almost a full rotation, but we don't quite get there. We have this much left over. That's the nearest x-axis, so it's the related acute angle. We know a full rotation would be 360, but we only went 30 degrees. That means I've got an extra 60 degrees to go, and that's a related acute angle. Again, understanding related acute angles is more important than memorizing how to get them. For example, if you look up here, we had to take 180 minus our number to get 80 degrees, but that doesn't work all the time. This one, we had to take 360 minus our angle to get our answer of 60. So there's not one way of finding the related acute angle. You have to figure out what the situation is and understand how to find it as opposed to memorize it.